Hello data nerds, what's up? I'm starting this series to discuss a very important topic, which is SQL. So if you are an aspiring data analyst, or you are in data engineering field, or you are even a backend developer, SQL is one such skill that all of you need. It's a widely used skill and widely required skill as well. It's very important that we have our concepts clear, we know how to write queries, we understand how the data is stored, how the data is retrieved, how the data is updated, and things like that. In this session, I'm not going to jump on writing the queries. We are just going to understand the theoretical part of SQL, like what is SQL, what is a database, what is a primary key, what is a foreign key, how data is stored in database, and all these stuff, right? So let's get started. So the very first question which comes to your mind is, why do I need to learn this SQL? What is the importance of this skill in the market? So to answer your question, as I already mentioned, that SQL is one such skill which is used by data analysts, data engineers, backend developers. Now the second question comes that which industry uses this language? To answer your question, there's no limit to which industry uses this skill the most, because all the industries have data. They all store it, they all want to extract it, they all want to analyze it, right? And for that, they need a language which can communicate with the database. Hence, all the industries use this SQL language, okay? Now, as it says that it helps retrieve and analyze large amounts of data, which is very important, right? And it is used behind the scenes in apps like Amazon, Netflix, and Instagram. Then comes, what is SQL? If I have to explain you in one line, then this is how it goes. That SQL, which stands for Structured Query Language, is a programming language used to communicate with the database. Now, even before we understand SQL, there's an important word, database. It's important for us to understand and visualize what is a database in our head. For that, first we'll understand what is a database. If you would ever talk to your parents, ask them, the way data was stored was very different. It was not in the computers, but it was all on the papers and the registers and the manual folders and paper folders, the notebooks. That were the places where we stored our data. And time to time, whenever we needed it, we manually searched for whatever we needed, and we had our ways to search for it, which was, of course, time consuming and very lengthy. Then technology intervened, computers came, and we upgraded. We started storing that data from paper to computers. So now the folders which we had on papers, now we had electronic folders. Now we have files, we have folders, we have documents, we have sheets, but everything electronically. So now we are not storing anything manually, but everything inside the computer. So that was the time when a database was introduced. Now, if you go by the definition, it says that a database is an organized collection of data that is stored electronically and can be easily accessed, managed, and updated, right? It helps store large amount of information in a structured way so that users or applications can retrieve it and analyze it efficiently. Imagine you sell books, okay? And you sell books to students across the country. And all the data of your sales is recorded in a database. But time to time, maybe weekly, monthly, or quarterly, you want to extract few data and want to analyze it. You want to see that which city is performing well, in which state I'm able to sell more books, or maybe where I'm not able to increase my sales. These kinds of information you would want. For that, what do you need to do? You need to communicate with your database. You want to write a language which your computer understands, which your database understands, and whatever you ask, they answer your question. That's what you would want. For that, a language was built called Structured Query Language, which was easier for computers to understand, for databases to understand, and for us to. Hence, if you go by definition, it says that Structured Query Language is a programming language used to communicate with the databases that we just understood. It allows users to store, retrieve, update, and manage data stored in the relational database systems. Again, warning alert, there's one new word coming, relational database system. We'll understand this word in a while, but currently just understand that there's a type of database which stores data in tabular format, in rows and columns. And if you want to store the data, if you want to update the data, you want to extract the data, for that you needed a language which computer understands and you understand it too. For that, a language was built which was called SQL. Okay? As I told you that you can retrieve data, you can insert new records, you can update existing data, you can delete records if you don't want them. So it says in simple terms, SQL is the language we use to ask questions from the database. There's a word which says relational database systems, right? So what is this relational database systems? Do you remember we just understood a database, correct? Now, there are different types of databases, okay? We have relational databases, we have NoSQL database, we have hierarchical database, and then we have network database. Now first, I will explain you everything apart from relational database in short, because other databases are of no use if you're learning SQL, because SQL only works on relational databases, okay? So we'll understand all the other databases in short, and then we'll jump on understanding relational database, okay? So first one is NoSQL database. What is NoSQL database? It's designed to store unstructured or semi-structured data and does not rely strictly on tables. I told you, right? Relational database stores data in tabular format. So it has rows, it has columns. But this NoSQL database does not rely on such formats. Okay, so we have few NoSQL database like MongoDB, Cassandra, or Redis. So these databases store unstructured data or semi-structured data. Then comes hierarchical database, where data is stored in a tree-like structure. I think it was very evident from the name that the data will be stored in hierarchy. So what will be the structure? Tree-like structure, where each record has a parent-child relationships. Okay, example, IBM IMS. Then comes network database. It is similar to hierarchical database. The only difference is it allows multiple parent-child relationships. Okay. Then comes the fifth one, which is object-oriented database. It stores data in the form of object, and one of the example of such database would be ObjectDB. Okay. Now comes the very important database which we are going to use, and that is relational database, right? Since SQL works on this kind of database only, hence we are going to study this in detail, right? So what is a relational database? Relational database is a type of database where data is stored in rows and columns in a tabular format. Now that table is also called relations, and these tables are connected to each other using relationships. Okay, as you can see, each table contains rows and columns. Here the rows are called records and the columns are called fields. Now, one database might have multiple tables, hence we structure the tables in such a way that we can establish relationship between the tables, right? So we can also say all these tables inside a database is related with each other. For example, let's see, we have two tables here. One is customer table and then we have orders table. So customers table have this data of customer ID, then we have name, and then we have city. Then we have orders table which has order ID, customer ID, and amount, right? Even though we have primary key and foreign key coming in the upcoming slides, but I want to give you an overview of what are these. Let's understand that. Now you can see in customer table, we have a column called customer ID. Now understand it very carefully. In customer table, this customer ID will always be unique. Means you have one customer Rahul, and Rahul is given a particular customer ID, so that 101 customer ID will not be repeated in any other rows in the customer table. Okay, I'm talking about customer table right now. In the customer table, the customer ID of a customer will be completely unique. If Rahul has 101 as customer ID, no other customers are going to get that customer ID. So that is going to be unique identifier of that table. Okay, now imagine Priya. Priya, we have another student as Priya who has customer ID as 102. In customers table, that 102 will only appear once in one row. But if Priya orders multiple books in 1 month, then in the orders table, Priya's customer ID is going to be repeated, right? Suppose Priya ordered one book on 5th March. So she ordered one book on 5th March, then she ordered second book on 10th, and then 15th, and then 20th. So any day she buys a book, one row is created dedicated to Priya and her customer ID, which is 102, and one new row is built. So if Priya buys 10 books on 10 different days in March, then in orders table, 10 different rows will be created dedicated to Priya. So see, this time customer ID is getting repeated in the orders table. But if you remember, in customer table, the customer ID of each customer was not getting repeated. So that is the difference, that when a column is a primary key in one table and when it becomes a foreign key in the another table. That we'll understand here. So customer ID, which is a unique identifier in customer table, will be a primary key in customer table, and the same customer ID would become a foreign key in orders table, because now that customer ID is helping us connect this orders table with customers table, right? Hence, it's called foreign key in the other table. Now we have multiple orders coming from Priya and it's getting stored in the orders table. But ultimately, if we want to establish a relationship between orders and customers, then we can establish this relation using the customer's ID, right? That's how a foreign key is helping us establish a relationship between customer table and order table. So it tells us that your one customer which you have stored in one row has placed these many orders. So that was an overview which I gave about primary and foreign key, which we anyway was going to study in upcoming slides, right? Now comes the tables. You already know what is a table, you know what is a column, you know what is a row. In relational database, all the data is stored in table format, and then we have rows and we have columns, right? Let's move on. I already explained you about the primary key, but if somebody asks you the definition, so you're going to tell the primary key is a column or a set of columns in a table that uniquely identifies each row in that table. Remember, uniquely identifies each row, okay? So Rahul has student ID. Now this 101 student ID will not be given to any other student. That student ID has been locked for Rahul. There's one more reason why, because names can be repeated, right? We can have multiple customers named Rahul. We can have multiple customers named Priya. That's why we give an unique identifier to each customer, which will not be repeated. So now this 101 customer ID, which we have given to Rahul, will not be repeated in any other rows. Okay, so hence that's why the definition of primary key says primary key is a column which uniquely identifies each row in that table. Then it says it ensures that no two rows have the same value and that each record can be uniquely identified. There are few rules about primary key, and they are: it must contain a unique values, it cannot have null values, right? So it's very important. A primary key cannot have null values because that is the unique identifier of that row, and the unique identifier cannot go null. So that is something very important to remember. Then comes foreign key. If you want to remember the definition, then it goes like: a foreign key is a column in one table that references the primary key of another table, right? It is used to create a relationship between the two tables in a relational database. As I already told you, that in customer ID, we had a primary key with the column was customer ID, and in orders table, the same customer ID became the foreign key because one customer can place multiple orders, and then the same unique identifier is going to be repeated in the orders table, right? But there's one important thing. In orders table, order ID will act as a unique identifier. So every time a customer places an order ID will be generated, right? And that order ID will be unique for that order only. So that order ID will not be assigned to any other orders. If Priya has placed 5 different orders on 5 different days, then 5 different order IDs will be generated for Priya. And same for Rahul. And even Rahul and Priya cannot have the same order IDs. So in order table, the order ID becomes the primary key. So that's why if you see here, it says order ID, primary key of the orders table, customer ID becomes the foreign key of the orders table, and then it says the customer ID in the orders table, which is this, refers to the customer ID in the customer table, which is this, right? So these two columns will be really helpful when we will try to establish the relationship between the customer table and the orders table. So this was it. I didn't want to add a lot of topics in the first sessions because I want these information to sink in. So we'll talk about the commands of SQL and the queries of SQL, the functions of SQL in the coming sessions. Till that time, study hard and meet me in the next session. Bye bye.